Dilutions. Dilutions is the process of adding more solvent to make the solute less concentrated. It is used to prepare solutions from stock solutions. Here's your formula. M1 times V1 equals the number of moles of solute, which equals M2 times V2. Now, the ones represent initial conditions, M stands for molarity, V stands for volume, and over here on this side, the 2's represent the final conditions. The M stands for molarity, V stands for volume after the dilution. I just want you to note that the number of moles are constant before and after the dilution, but what changes is molarity and volume, which are inversely related. In other words, one goes up, the other one goes down, or vice versa. And here is your equation. M1 times V1 equals M2 times V2. Here's an example problem. What volume of 16 molar sulfuric acid must be used to prepare a 1.5 liter of a 0.1 molar sulfuric acid solution? Remember, M1 times V1 equals M2 times V2. Okay, and we want to solve for volume. So when we solve for volume, V1 equals M2 times V2 over M1. Okay, we plug in our numbers and we get a volume of 9.4 times 10 to the negative 3 liters, or 9.4 milliliters. Here's another example. How would you prepare a 500 milliliter of a 1 molar solution of hydrochloric acid if you had a stock solution of 12 molar? Step 1 is to find the volume of the stock solution. Step 2 is to fill in the numbers here in your formula. So 12 times, I want to find V1, equals 1 times 0.05. 0.05 represents the 500 milliliters in liters. That's important. All volumes in our dilutions need to be in liters, not milliliters. Okay, and when we solve our answer, we get 0.042 liters, or 42 milliliters. Now we need to figure out, step 2 would be how much water to add to this 42 milliliters of our stock solution. Well, if we want a total volume of 500 milliliters and 42 milliliters of that make up the stock solution, well then we subtract 500 minus 42 and we need to add 458 milliliters of water. Okay, so your answer is 458 milliliters of water added to 42 milliliters of a 12 molar hydrochloric acid solution.